All right, good afternoon and welcome back to the NEUP webinar. My name is Richard Reister. I'm the program manager for the Light Water Reactor Sustainability Program. Last half hour we talked about an integrated research project supporting this program, and now this afternoon I'll talk about the four NEUP calls related to the Light Water Reactor Sustainability Program. And so I'll go through a quick, for those that weren't with us the last half hour, I'm going to go through a quick overview of the program, and then I'll discuss the four NEUP calls. So the Light Water Reactor Sustainability Program's goal is to facilitate the long-term operation of our existing nuclear power plants, as long as that can be done safely and economically. The focus areas of our program are divided into four, we call them pathways, technical pathways. Materials aging and degradation, advanced instrumentation, information and control technologies, the risk-informed safety margin characterization pathway, and the reactor safety technology pathway. I'll summarize these four pathways in a little more detail now. The materials aging and degradation pathway is the largest pathway. It's about a little more than half the program. It's focused on materials degradation, certainly metals, the more traditional area, the reactor pressure vessel, core internals, steam generators, piping, and balance of plant components. Some of the degradation mechanisms involved: irradiation-assisted stress corrosion cracking, high fluence phase transformations and swelling of core internals, high fluence effects of reactor pressure vessel steel, cracking initiation in nickel-based alloys, thermal aging of cast austenitic stainless steels, and environmentally assisted fatigue are the key areas. In addition, though, some of the more non-traditional areas are being looked at, and that's concrete. We have a joint research plan with EPRI focused on radiation effects and non-destructive monitoring tools as well. In the area of cables, we have a joint research plan with EPRI and the NRC to better predict and monitor cable aging. And finally, we're looking at mitigation, repair, and replacement technologies, in particular weld repair techniques, post-irradiation annealing, possibility of doing a reactor pressure vessel annealing, for example, advanced replacement alloys, and advanced non-destructive examination techniques. In the second area, we have advanced instrumentation, information, and control systems technologies, and here we're addressing the long-term aging and reliability concerns of the existing technologies and developing new and develop and test new technologies. We're working with industry to establish a strategy to implement long-term modernization of these technologies and developing the scientific and technical basis to support the safe and efficient plant modernization, mostly with digital technologies, I would say. And even though there's a picture of a control room, we're looking at the control room modernization, certainly, but we're also looking at a lot of other areas of the plant in terms of field workers and field systems, not just in the control room. The third area is the risk-informed safety margin characterization area, and here we're looking developing margins analysis techniques, including a methodology for carrying out simulation-based studies of safety margin. To do that, we are developing tools. We call them the RISMAC toolkit. Foremost, we have the RELAP 7 code, which is a systems code to simulate the thermal hydraulics behavior at the plant level. And it uses advanced computational tools and techniques to allow faster and more accurate analysis. Raven is our simulation controller, and it provides input on plant state to RELAP 7, and it integrates the output of RELAP 7 with other considerations, such as probabilistic information and procedures, and determines component states. So operator actions would be part of the Raven code. And then aging simulation code, Grizzly, we're looking at the aging of components. And initially it's focused on the reactor pressure vessel degradation, but we're also looking at, or we're also in the process of developing Grizzly for concrete degradation. And the fourth area, reactor safety technologies, is really focused on the lessons learned from the Fukushima accident. Some of the focus areas are addressing the long-term core cooling concerns during a potential station blackout scenarios, helping to inform potential revisions to the severe accident management guidelines by understanding severe accident modeling uncertainties. And then finally, we're collaborating with the Japanese and other international partners in terms of planning for the forensic activities at the Fukushima plant as it's decommissioned. So that was a very quick summary of the light water reactor sustainability program. And now I'll talk about the 4 specific technical areas involved in the calls. The first one is related, focus on the materials aging and degradation pathway, RC4. Materials and components under extended service conditions may see very long lifetimes under stress, temperature, corrosive chemistries in the coolant, and neutron or gamma radiation fields. The expanded materials degradation assessment was published by the Nuclear Regulatory Commission, but it was actually a joint project between NRC and DOE, and it identified the potential knowledge gaps in materials degradation areas. The LWRS program is addressing a number of these knowledge gaps, but some important areas are not being addressed. Therefore, research proposals are desired to address some of these gaps. Specifically, the gaps are identified in the following areas listed on the slide. I can summarize them real quickly. The effects of irradiation on fracture toughness, irradiation creep, swelling, and stress corrosion cracking for 308 and 309 stainless steel weldments. Stress corrosion cracking susceptibility of very long lifetimes for 304, 316, 308, 309 weldments, particularly in boiling water reactor normal water chemistry environments. The potential impact of poor water chemistry control and service water on crevice corrosion, pitting, and microbially induced corrosion for 304, 317, and 308, 309 stainless steel weldments. Potential impact of thermal embrittlement on low alloy steel, reactor pressure vessel components, and dissimilar metal weldments. Creep crack interaction in concrete structures due to structure modification or changes in loading. And finally, mechanistic understanding of the effects of long-term wetting on low and medium voltage cable installation. And there may be others. If you look in the EMDA, there could be others, but right now these were the areas of particular interest. Again, these are areas that are not being researched by the LWRS program that are important, but right now aren't within the scope of the funded research for the program. And so we're looking for proposals from NEUP universities to address these particular areas. So should I pause for questions now? Perhaps that would probably make sense.
Yeah, we can pause for questions now for the RC4 area. As we go through all of these scope areas, as you ask questions, please in your question note whether it's for RC4, 5, 6, or 7, and that will make it a little bit easier to address the questions in a more orderly fashion. Rich, the first question is RC4 has 2 parts. One is flow-assisted corrosion. Are we supposed to work with INL for that?
Well, you certainly don't have to work with INL for that. You say flow. I guess I'm not seeing that. I'm not seeing flow.
He said it was for RC5. So
we'll cover RC5 in a minute. I was
okay.
asking questions for RC4 at this point.
Here's an RC4 question.
Okay.
For the creep crack interaction of concrete, should the grizzly be used, or can we develop our own code?
I would say either one is acceptable. We would probably prefer something with the grizzly code, but if there was another code that would be applicable, then that would be fine as well.
Do we include hot cell charges of looking at irradiation effects on toughness for RC4, or is that also included in an NSUF proposal?
Well, if you wanted to use radiation facilities, I would recommend you do it through an NSUF proposal. I'm not really you guys could probably answer this question about the NSUF proposal and these NUP proposals if they're trying to get funding for how does that interaction work?
Only in one area, not two areas.
So how the NSUF access works is you can only propose R&D joint with an NSUF access proposal in the NEAT NSUF 1 area. And Rich did present earlier this morning on 3 areas related to LWRS that are eligible for NSUF access with R&D support. So refer back to that presentation once it's posted online for more information on that. On RC4, would proposals based solely on computational modeling of materials degradation under irradiation be considered?
I would think they would be considered, but if I don't know if Jeremy Busby or one of those folks is online.
Jeremy isn't available today, so
okay.
we'll have to clarify that question with Jeremy, and we'll get an answer out in the online webinar-specific question and answer.
Okay. So now we'll cover RC5, and this is related to the Instrumentation, Information, and Control Systems pathway. And this is signal processing to detect component degradation. Improved methods to detect and characterize the degradation of passive components operating nuclear power plants is desired. Proposals are sought to develop the advanced signal processing capabilities related to active or passive sensors. So again, the focus here is on advanced signal processing capabilities. In particular, capabilities related to alkali silica reactions in concrete as well as flow-assisted corrosion are desired. A flow-assisted corrosion test rig and sensor network is under development at INL. The desired outcomes include the development of structural modeling framework, diagnostic indicators, and prognostic parameters. And I think the question we had before was, would you have to partner or use the test rig and sensor network under development at Idaho National Laboratory? And the answer is no, you wouldn't have to, but because we have this test rig and sensor network under development, it would be available for use as part of the proposal. So we just want to make sure applicants were aware that the facility was under development, is available for their use.
Okay, moving on to RC5 questions. Is RC5 only for alkali silica reactions, or other degradation mechanisms applicable? Or are other degradation mechanisms applicable as well?
Other mechanisms are possible, although there was a desire to have alkali silica reactions in concrete as well as the flow-assisted corrosion are considered more desirable.
RC5 has 2 topics. Do we need to address both topics in our proposal?
No, you can just have one or the other.
Now moving back to a question for RC4. Is cladding included within the scope of RC4?
No.
Right, that's all the questions we have for RC5, so we can move on to RC6 now.
All right, RC6. This is focused in the reactor safety technologies area, and it's modeling an extended loss of coolant accident. Observations from the Fukushima accident indicated that there may be alternative strategies to better address extended station blackout scenarios. Additionally, the recent industry initiative to implement flex equipment and research on the potential use of accident-tolerant fuels will also impact potential plant response to station blackouts. Plant simulation studies using advanced modeling codes and techniques are desired for station blackout scenarios. The methods should address the code uncertainties and help evaluate the effectiveness of flex equipment, alternative operational strategies for passive heat removal systems, and alternative fuel designs. And so, again, it's using really the RISMAC type codes that we discussed to look at the station blackout scenario. And again, with a focus on validating some of these methods that have been proposed to address the station blackout scenarios, flex equipment, alternate operation strategies. An example of that would be at the Fukushima accident, the RIXI pumps were allowed at one of the plants to operate essentially not manually governed or even automatically governed, but just in a natural mode. And it appeared to start and stop several times on its own. So that might be an example of an alternate operation strategy, but there could be others. And again, advanced fuel designs in terms of the accident-tolerant fuels that are being developed in the other program.
Is the proposal that is mentioned to use, in the proposal it is mentioned to use relapse 7 for SBO transients. Is this the only code that can be used for the proposal?
No, other codes could be used. We would probably prefer to use relapse 7 because it's the RISMAC Moose-based code, and we're trying to integrate some of these code techniques with the RISMAC program, but other codes could be used. This type of analysis has been done with relapse 5, for example. But it's a lot, in our view, it's a lot harder to do with the legacy codes than it is with the newer codes. And we're trying to move the ball forward with the new codes.
This may be a similar question, but does familiarizing yourself with RISMIC codes, is that a request or a pre-request for submitting an application? You need a detailed knowledge, I guess, of relapse 7.
You don't need a detailed knowledge, but our desire is to, part of the program is to get people more familiar with these new codes, and so that would be part of the process would be, and exercising these new codes by other people, so that's certainly part of the process.
Okay, we'll continue fielding questions for any of these LWRS areas, but we'll now move on to the RC7 area.
Okay, RC7 is in the risk-informed safety margin characterization area, and it's validation of the relapse 7 code. The LWRS program is developing the relapse 7 code, a next-generation thermal hydraulics plant simulation tool based on the Moose capabilities. The complexity of these new models and associated computational methods present significant challenges for code validation. However, some level of code validation is required before these codes can be used by industry. Proposals are sought in the following areas: a survey of additional data and data gaps, building on reports generated by the LWRS program and the LWRS program partner EPRI, acquisition of new validation data from existing facilities, synthesis of this data into a form that can be used in relapse 7, and validation of relapse 7 models against existing data, acquisition of new validation data from new facilities and experiments, and identification of additional experiments needed, if any. And that last point, I would kind of emphasize, we can certainly identify additional experiments, but I wouldn't preclude new experiments, but I would say that's not the emphasis, is to do to build and run experiments to obtain validation data.
Would improving relapse 7 modeling be part of the work scope?
Well, certainly if there was in the validation process, there was some inconsistency between the data and the code, that may in turn, why is there an inconsistency? And so that might lead to improvements in the model that's used, the underlying models that are used in relapse 7 code. So, and some of those improvements could be suggested as part of that process. So, I guess the answer is yes, it would be.
Okay, great. So when the earlier question was about modeling of creep interactions in concrete, and is a modeling entirely approach acceptable? I think I'd echo Rich's comments that would be okay. I guess personally I would like to see at least a validation plan or tie into some databases. This particular mechanism has been studied fairly extensively by the Department of Transportation, but not for nuclear applications or nuclear structures. So there may not be any experiments required, but I guess personally I would hope to see some sort of validation approach to back up the model.
So this next question is for RC7. Is there interest for development of new statistical validation tools?
If they're specifically applicable to relapse 7, I guess that would be okay. If it's sort of non-traditional, sort of novel things, that might be better suited for the IRP call. But it would depend on the details of the proposal.
This is a question for RC5. Are you also interested in new NDT or sensing technologies, or only in signal processing methods?
Principally in signal processing methods, but if there's a signal processing method that you're considering that could be coupled with a new type of sensor, for example, then we would also be interested in that as well.
All right, moving back to RC7. If code is developed by an industry partner, does it have to be finally owned by DOE or a research collaborative agreement, or can a research collaborative agreement be made?
The RC7 call is specifically for validation of relapse 7, which is under development by DOE, and so I'm not sure what this other code that they're talking about. Is there more details of the question?
There isn't, but we can have the PI submit another question that may clarify.
Okay.
Moving on, another question for RC7. When will a relapse 7 license be made available to universities?
We're working on actually licensing for all of the RISMIC toolkit tools themselves, and so right now it's basically licensing for specific universities for specific collaboration activities, and so we would do the same for the NEOP call.
So I just got clarification for the last question. The code development question was in regards to RC4.
So I think the question, if I take it,
The question was, is something developed by industry DOE owned, or is there some type of cooperative agreement that can be placed that has a different arrangement than that?
I believe that a CRADA may be used in that instance. That's generally an agreement with the federal government. So if your university has a similar type of agreement that recognizes developed intellectual property, that would be the appropriate instrument to use.
Moving on to another question in RC4. Are any of the samples for study on the effect of irradiation on fracture thoroughness, creep, or SCC, will they be provided for the PIs?
Well, I think that would depend on exactly what they were proposing and if they even existed. Through the NSUF, there's a fairly extensive library of pre-existing specimens that could be tapped at a very little cost, certainly compared to creating and radiating and transporting them from scratch. I think that would depend a lot on the specific conditions the proposer were looking for, and even if they existed. But there may be options to use an existing library, but that might take a little detective work.
Moving on to RC7, is there interest for development of new statistical validation tools?
Yeah, I think we answered that question once. That if it's a novel approach for validation, it might be better suited for the IRP. But if it's applicable to RELAP 7, it could just be okay for RC7.
Another question for RC7. Is there interest in RELAP 7 validation for non-LWR reactors?
We hadn't thought about that. I think since it's part of light water reactor sustainability, I think the emphasis would be for the current fleet of reactors. Rich, I don't know if you want to.
Yeah, I would echo that. This topic is under the purview of the light water reactor sustainability program, so our interest is in light water reactor technologies. I know that RELAP 7 is being developed for non-light water reactor applications, but I think that would be a different call to validate RELAP 7 for those applications. Where this call is for light water reactor technology or light water reactor uses for RELAP 7.